somebody posted a question about colonization of Mars, and this like crazy dude responded with a like 20,000 word essay about colonizing Venus instead. And I can send you a link to that if you really want to read it. It's actually so awesome. But once I found the idea, actually I discovered references to it in a lot of places. There's several prominent papers that researchers at NASA have issued. There's been a story on Medium. It's been featured several times on Slashdot. It's been all over the place. But basically the idea is to colonize Venus, but not on the surface where it's 900 degrees Fahrenheit and the atmospheric pressure is 100 times that of Earth, so it's kind of like a living hell. Instead, you colonize it in the clouds, 50 kilometers up, where atmospheric pressure is about equivalent to Earth's atmosphere, one atmospheric pressure, and the temperature hovers somewhere around 0 degrees Celsius, depending whether you go higher or lower. And the reason it can work is, is that my next slide? Yes, I don't know if you can see that. So this is some stats about the surface, the atmospheric pressure. Venus is actually closer to Earth than Mars is. It's only about 0.3 AU, whereas Mars is about 0.5, which means you can get there in 6 months instead of 9. And the atmosphere is made almost entirely of carbon dioxide, which is significantly heavier than oxygen and nitrogen. If you have a bubble of our atmosphere, nitrogen and oxygen, on Venus, it's about 40% buoyant. So for every kilogram of it that you have, you can lift another 0.4 kilograms of something else, which is an interesting way to think about it. This is a couple of charts I found that show where the habitable zone is, which, like I said, is about 50 kilometers up. It's actually about the transition between the middle clouds and the upper clouds. So I guess I don't have a mouse pointer, but like it's in this weird zone. So Venus has these basically sulfuric acid clouds. They're totally awesome. And the upper clouds are like a super fine mist. It's a mist that actually the visibility should be about 10 kilometers. And then there's a middle layer of clouds that's more like the kind of mist we're familiar with here, where maybe you have a visibility of a few hundred feet. And then there's a bottom layer of clouds, which are the ones that actually prevent us from seeing the surface, which are nearly equivalent to our clouds, where visibility is merely a few feet. So the habitable zone is actually somewhere in the middle layer of clouds. Visibility would be several hundred feet. It would still be relatively bright. In fact, it would probably still be brighter than it is here on Earth, because Venus has sunlight that's about 30% stronger than Earth. So even after you take out the stuff from the haze above you, it's still really bright. And bizarrely, it's actually nearly as bright looking down as it is looking up, because those clouds below you actually reflect 90% of the light that hits them, which is why Venus is so bright in our night sky. So you could have solar panels both on the top of your colony and on the bottom of your colony. And then the Russians actually did a whole bunch of research on this in the 70s and 80s, and they proposed these like kind of brutalist like colonies where you have like this massive amount of like concrete and these huge like landing zones and then a big dome above them. Obviously you don't have to design that way. You can design in any way that you want. I think actually one of the exciting ideas about colonizing the cloud cities is basically any shape that you could make buoyant is a potential colony. So as long as it has a large enough volume on the inside to support the material of which the colony is composed, you can make it go. There's obviously going to be a lot of caveats in that. I think probably the largest danger on Venus is not the sulfuric acid. That I think is relatively livable. It's not particularly dense. It's about 90 parts per million, even at its worst. The largest danger is weather. Venus has like an atmosphere that is 100 times the size of Earth. So by my reckoning, it should have weather that's about 100 times as bad. Hopefully it wouldn't be bad at height, but it does have what are called super-rotating clouds. So the whole atmosphere actually spins around the planet at about 400 kilometers per hour. And you would ride with that, which is cool because it means that your day is actually about 48 hours long and your night is about 48 hours long. If you were on the surface of Venus, the planet itself is nearly stationary. It's 117 days, I think, to rotate. Your day and night would be very long. But in the clouds, it's about 4 days, 2 on and 2 off. But obviously, any small disruption in the super rotation would be relatively serious for your colony. Like, you don't want to have crosswinds for your gigantic airship of even 10 or 20. So one of the big research agendas in terms of the actual feasibility of this idea of cloud colonizing would be to figure out, is the weather A, either not so bad, or B, avoidable in some smart way. Maybe you can hang out at the poles, maybe there's an altitude at which it's more reliable, maybe storms develop slowly and if you had satellites you could move out of the way. There's lots of ways it could work. And then, of course, the other thing, I have a picture of a terrarium here. The other thing that I think is really obvious about cloud cities is you have the space and the ability to do basically arcologies. That would be the way that the colony would actually develop. You have a gigantic sphere inside of which you're running an entire ecological system. You have everything you need to grow all of the food and material. I think actually your large building material on Venus is probably wood, which sounds a little bit strange because it's not very high tech, but it would be really achievable. You certainly have lots of carbon dioxide, you got lots of sunlight, you can import some trace minerals. You're going to need your potassium, your nitrogen. You probably get nitrogen from the atmosphere. You need your salts, all kinds of stuff like that in small quantities, which you import either from Earth or you put an asteroid in the orbit of Venus. You mine from that. On the scale of building a colony, getting an asteroid there is minor. Obviously, a potential other thing you can research other than sending probes to Venus to figure out weather is to figure out how to do this like self-sustaining arcology thing. And I just read a really fabulous science fiction book, which I recommend, called The Water Knife by Paulo Guglielmi. He wrote The Wind-Up Girl, also a good book. But basically it talks about how in California, Nevada, Arizona, and Texas, global warming is predicted to dry all of these places out immensely. And they're all going to have serious water problems. And one way to solve serious water problems is to fully enclose arcology habitats, kind of like skyscrapers but on steroids, where inside the skyscraper you're recycling all of your water, all of your nutrients, everything, and just not interacting with the outside world. So you prototype that idea here, in Texas, in Arizona, in Nevada, and then later you do it on Venus. Yay! And I think that was the end. Yeah, that was my last slide. I don't have a website yet, but I'm looking at getting venus.cloud because the new TLDs are totally awesome. So if you're interested, talk to me. I think it's a cool idea. Obviously, it is the least practical project I've ever done. But it's certainly fun to think about. And I think here, my other tagline, there's Mars. Living on Mars is like living in a basement apartment, because you're going to be buried underground to protect yourself from radiation. Living on Venus is like living in a skyloft penthouse. You're going to be up in the clouds, full sunlight, massive amounts of room, because by definition you have to have, in order to support just your weight, you've got to have freaking several hundred meters cubed of air. Going to be lots of space. Most of it's going to be empty space, but anyway, thank you.